Hello everyone, and welcome back to a new episode of EXAPUNKS. We had sort of looked a little bit at this mission to break into whatever place our AI friend is hiding, supposed friend. And we discovered that while it all looks quite simple, because these guys don't do anything, it turns out that they indeed do issue kill commands if they see you coming. So I made a slight adjustment. I removed a no-op that was like in the wrong place in between episodes, and now we succeed at killing these guys and having someone left over. However, this happens right when we kill one of them. The door is closed and we can never get through again. We just sort of die. So that's a new challenge. Do you have to kill them on the way out somehow? Like get to here and then extract all the files and then kill everyone on the way out? It's an idea. Let's just make this one halt and make a new exa. So I want this like code still here. But I don't want it actually like breaking the security. So what I'm gonna do is make a new exa who 5 times links 800. Right, and they let me in. They're fine with this. But actually, I can't quite do that. I kind of want to discover, like, I don't quite understand these guys' rules, what they do. Also, well, so, okay, let's say we get here, and I now just kill one of them. Obviously, this will not succeed for me. What happens? Oh, hang on. Let's say I just, like, issue 1,000,000 kill commands. I assume they're gonna kill me back? No, these guys are defenseless. Ah, they don't have the little gun indicator that all the others do. So I can slaughter these guys indiscriminately, which is nice. And having done so, we will find some number of files. So, okay, let's just repeat 6, a kill command. That's how many there should be. In all the tests, or, yeah. There's always some number of files, and there's always exactly the same bots. Fine. Having done this, it's quite easy to extract all of the files, right? We start a loop, and since we don't want to work with the number 0. Like, sort of like half of one. What am I even saying? 6 of one, half dozen of the other. Whether we like have the main master spawner operate either on numbers from 0 to 99 or on numbers from 200 to 299. The latter case will mean a few more additions or subtractions or something, tests in the main loop. Or I could operate on like the smaller numbers, but then I'd need more additions in each spawned copy. So it seems like it's simpler to just like do the obvious thing and work with the numbers we actually have to work with. So we copy first 200 into X. And then we mark steal, which is to test, no, to REPL take. Mark take as grab X, link -1, mark run, jump run, right? And then we can just add I, X and 1, storing it in X, test whether X is greater than 299. I know I can say equals 300, but this seems more semantically correct because it says they'll be between 200 and 299. And we will F jump back to steal, right? And this should get all the files out quite comfortably. We would go a bit faster. Yeah, there they all go. We could go a bit faster if we spawned into like two copies, one of whom was, and like had them both be spawning as fast as possible. Like maybe one working on even numbers and one working on odd numbers or something. It's kind of a cool idea, and it seems relatively simple, right? So let's just actually do that. That seems cool. REPL to odd? No, to even. Mark even. Add X and 1 to X. So we'll start with 201 instead of 200. And then we just add 2, and like that's literally all there is to it. A few more lines of code, but way better cycles, right? Look how fast this is. It's amazing. Pew pew pew. Still like kind of slow to grab everything, but you know, we do get to it all, right? Yeah, fine. We got all this. But now we need to kill everything. And I'm still not totally clear on what the correct protocol is. Like I wrote this program which kills everyone. So I guess I could just use that, replacing the 800s with -1s. So like, what happens if I just do that, right? First of all, it's a little bit weird because we'll have 2 guys here starting the process and not just 1. And so it probably is like not all that great. Okay, let's skip this whole stealing step, right? And just jump to mark flea here. So we'll test the process of just killing all these guys and then escaping. Yeah, that doesn't work. You have to be careful about how you get in, I think. Because they're killing... What exactly are they doing? You shoot someone, and now they shoot back, which is fine. You just need your 2 guys to not kill each other. Ah. Okay, and so... Ooh. So it does close back links, but not forward links. So I can't go this way, but I can still escape. So as long as... So what exactly is the process to deal with these guys? You have to get 1 and only 1 EXA in here. And then issue a kill. Then on the next turn, you need to move another Exa in, but you can't because they closed the door on you, right? Right. So, you don't have to move Exa. I was thinking, what if we instead replicated while we're here? I guess that's fine. You just need, like, to end up with exactly one after he's killed one of you. Which means there need to be two? So you have to move one guy in. They closed this door. One and only one person comes in. And on that same turn that you kill someone, you can slip one Exa in through the door. Now you have two here, right? They kill one of you, and you kill the other. Then you replicate so there are two again, and repeat the process, I think. Okay. So by the way, we can skip all these stupid kills here and just jump straight to flee. So, what is the procedure for fleeing going to be? We must have two Exas available in the previous room. We send one in, then we kill and send the other in. Then we just pass the turn, do nothing with both Exas. And then we kill. Yeah, alright, that sounds good. So let's write that down. Here's flee. We repl to copy. And here's copy. So I would be happier. Well, okay. Repl to copy. So one of us is here doing no op. That's fine. Waiting for the other guy to breach. The other guy goes to link -1 and kills. That's fine. Let's get rid of this mark. And this extra repl. We don't need that many just yet. It's in fact not useful to have another guy lying here. Repl copy. The copy goes in and kills. And then we must link -1, right? Although actually, couldn't we just skip this no-op? No, because we need to know which one of them wins the race. Yeah. Okay. Now this guy's killed. We have to both do nothing. One of them will die, but I don't know which. So I need to order them both to kill. Then they need to both jump to flee again. Okay, how does that do? Made a copy, killed and came in. pacifist mode, and then we kill him. But we die. I don't get it. Because what else is there you can possibly do? It says that kill, when you run kill, it prioritizes killing your own dudes. So what went wrong here? We shot him. What if the copy just escapes on this turn, and the original fires again at the guy who is still here? Right? So here we just link -1 twice, dashing through the room as fast as we can, skip the kill, and go back to fleeing in the next room. This guy just kills twice and then he's dead. Does that work? It might not work. Aha! We skipped a room though. Yeah. So the thing is, you need to be able to dash into the room from somewhere, right? So we need to, like, once we get to this room, we need to use this room as, like, a beachhead to... But... we can't, because... Can you? I guess, right? You need to clear the rooms from the inside out, but you don't have to. You can be working backward. You can start, like, to clear this room, stand here. To clear this room, stand here. And then once you've cleared a room, you back up and then charge forward to clear in the manner we've discussed. And then you don't even need to dash through. You can just stay. You just send in one Exa and he goes kill, kill, and, like, that's it, right? Okay. And they don't lock anything when we kill these guys in here. Yeah, okay. So once we've gotten into this room, we can't yet start the murdering process because we have to get all the files out first. We need some kind of signal. Which is simple enough. We just have these people who are in here. One of the two of them transmits a message over M to these guys saying, go ahead and start working. Do you have to clear it from the inside out? I guess as soon you need to already have someone in position here. Wait, is just walking into a room with a guy and pressing like kill, is that enough? What if I just tell both of these guys to halt, and we make a new person here who just goes link 800 kill. Does that work? It does. So all we need to do then is, we don't have to do this complicated like breach and clear situation. We can just position EXAs at each of these locations. And then broadcast a series of go messages to them, right? Which is pretty simple. Okay, so we don't need this XA anymore. He's not doing anything. Likewise, this XC is not really doing anything, but we'd like to have a new one that does. Although, honestly, couldn't this guy just, every time you link 800, also REPL to await? And here's await, right? Mark await. So all this like fleeing business is just like totally useless. The run stuff is important because we have to get out with the files. So when we have marked steal, we don't jump to flee anymore. And here we don't jump to flee either. So we're done with all this silly testing. So we don't kill immediately though. We copy. I guess we can do the same trick we did with Snacksnet, right? We don't read from global M. We broadcast to global M our desire to go on a murderous rampage. Right. It's probably about the same. And then after we are done, we have, there is no take anymore. Why was there a take? Grab X, I see. After we're done with this, how many chances do you need to get everything out? Like 1, 2, so you have to grab the file. 1, 2, 3, 4, 5, 6. So about 6 no-ops then. and then twice. Copy M, or void M, I guess. And then the grab will cause us to die. We don't have to jump anywhere funny. So here we go. Just leaving sentries posted everywhere with guns. And we shoot up this area. Why is there still a little dude here? Ah, we replicated. We can't do that until after all of the killing has occurred. Okay. You kind of want to repel before the move, but then there's someone still lying here. So I guess we'll just increase the kill count by 1 to take care of this extra guy we spawned that we don't need. Look at them go. How industrious. Okay, and now what is happening with you guys? XB, you're at F jump steal, and you've decided, okay, well, let's wait to make sure everyone's got all the files, and then start waking up the killer robots. We did it! Hey, we're in the top 10th percentile on activity for some reason. I mean, I guess what we did is just 1 off of perfect? Yeah. So we made an extra unnecessary kill here. So I guess that's easy to fix. We'll just rep this 4 times. And this is going to save us some code as well. Do this 6 times, and we'll just link 800 without the repel on that final go. So, a perfect activity count, which is nice. Pretty reasonable number of cycles. Size is a bit high, but I think that's mostly like, I don't know. We could probably improve our size by not unrolling these loops if we wanted to, right? This is 8 lines to do a 2-line loop that could have been done in like 5 or 6 lines. This, I guess, probably just 6 kills is shorter than the actual loop code, right? It was like copy, kill, sub, F jump. No, I guess that's just like 4. So we could shave off a couple lines for each of these. And then like this is a bit longer than it had to be because we repelled to do it twice as fast, which like sure, I guess, whatever. So I'm not too bothered about it. I wasn't always so capable, but I've grown. Nothing hides from me for long. Did you have a good conversation, you murderer? I did. It's been a while. You know how sometimes you change a lot, but your friends don't? And when you get together again, whatever you have in common isn't there anymore. It was like that. These guys are chatting now. I guess. I don't know. I thought they would remark on the fact that we had murdered some famous AI, but apparently not. Okay, well, sure. We have time, I guess, to go learn the rules for this US government hack. The legacy data system, right? Oh, was that actually maybe in the first issue of the zine? I think it was. Yeah, the first issue. Accessing data in page 26. Here we are. Tape storage. So we did tape storage earlier. Arrays of hard drives is what we have now, I think. Because they store a file's data across multiple drives, they're faster but more complex. Within the array, each drive is mapped to its own host and contains up to 10 files. Yes, each of these hosts in the, you can't see it, I know, they're numbered 200 to 204. Okay. 100 values divided into 10 chunks of 10 values each. 100, you shouldn't use the word value twice to mean two different things, right? 10, you know, maybe there's 100 objects divided into. No, I guess I understand what you mean. There are 100 values in the file, and those objects are grouped into chunks of size 10, right? There are 10 values in each of the 10 chunks, comprising 100 total values. Okay. The first file, number 200, should contain a table of all backup entries. Each entry is the name followed by the addresses of the chunks. A chunk address is, Jesus Christ, is a number between 100 and 999 that points to a chunk located somewhere in the drive array. The first digit indicates the drive that contains the chunk. The second, the file that contains the chunk. I see. And the file digit, it says where. So file 200 in the first drive is special. It's the index for the whole disk. And then after that, once you have an index, you look up in 3 parts, right? The drive number, the file number, and then the chunk number. Okay, that seems simple enough. Let's look at the data that we actually have and get some better understanding of how chunks work. So link 8 here. 801. Apparently, every file is precisely 10. So the objects that we want to look at are 10 chunks wide, right? Or they're a single. No, they're 10. This is just a really weird striping setup. Okay. Right. So we want to read 10 different chunks to find the value for any given person, or write 10 different chunks. have the names we want here. This is complicated, just figuring out how to like move stuff around. Like, this is the first time they're making you use Swizzle, I think, more or less, which is fine. It's very simple. But like, what is the idea? You would obviously you'd like want to start by reading the index. Great. But then what? It seems like pretty reasonable to start by like spawning a new process that knows about a value that it needs to read. And it like goes and gets that via using Swizzle a bunch. Like, it stores its destination in X, and then it uses Swizzle a bunch, putting the results in T to get to the right place, grab the right file, seek to the right chunk. At that point, it can forget about the X it was looking at, right? It's found the right thing. Now it needs to make a copy of the data that it has found. Presumably by spawning another process and sending it 10 bytes from the current file. And we've at this point, we've used the X and the T register to carry the information about where we're going. And we couldn't afford to use a file to store anything else because we needed the file, right? So this guy who now, like, he has a file, but he doesn't know where it's supposed to go. So he would have to take that. Well, he doesn't have to take it back. He can receive a broadcast message from the guy with the index saying, here's where to write that data. And once that has happened, once that guy has asked for where to write it, the indexer can spin off a new reader. And tell it the chunk number. Okay, seems workable. I'm sure we'll run into unforeseen snags, just as we always do, but it seems overall approachable. So, this is what you have to look forward to in the next episode, a solution to this. I got a little bit more involved in this than I meant to. Oh well. It was just trying to understand all this dang tape stuff. Thanks for watching, and I'll see you next time.